Hello and welcome to another episode of Better Together at Science with Shinrai Sensei. And previously we went ahead and we covered, gave a brief overview of the layers of the atmosphere and what order they go in, kind of which one's closest to the surface, which one's the furthest out, right? Well, today we're going to go a little bit more in depth, kind of go into each and every one of the layers. This episode, we're going to cover the troposphere, right? The troposphere is the closest to the Earth at 0 to 16 kilometers, and it also possesses the most air molecules because, obviously, due to gravity, the air is condensing towards the surface. So it's going to try to have all... The goal of gravity is to have all of the atmosphere compressed down to the surface as thinly as possible, and gases don't like to behave that way, so they're going to be, flowing around each other and trying to get up higher or go down lower depending on temperature and things like that. There are a lot of reasons why the atmosphere behaves the way that it does, and the reasons why we see certain things, right? But this is a rain cloud, by the way, so let me go ahead and draw some crude little raindrops or something here that shows what this is. Right? Okay. So, troposphere, closest to the Earth at 0 to 16 kilometers. Most air molecules are going to be found in the troposphere. And this is also the area where the most weather phenomenon happen, like your thunderstorms, your hurricanes, your tornadoes, and stuff like that are all going to take place in the troposphere. And, fun fact, when these storms get to be very large and progressed into a more severe storm, they are going to take on kind of this anvil shape, right? I tried to draw it, but I might not be very good at drawing, but I hope I can, hopefully this is a good representation for you. And here you find that the top of the troposphere is what we call the tropopause, and that's where you'll see storms don't go higher than that, so they press up against that tropopause and they start squishing out and forming this anvil shape, and so we call them anvil clouds. When you see severe thunderstorms and stuff like that, will form anvil clouds because they are building and building and building and building until they reach the top, and then they just billow over and start to press up against that layer and squish out and form this anvil top, right? And that, like I said, it's the tropopause right there. Also, the air is warmer closer to the surface because the heat comes from the surface, whether it be due to like volcanoes or fires, or if it's just due to infrared radiation that is reflecting off of the surface of the Earth. The majority of the molecules down closer to the surface are going to heat up due to that either reflected or produced heat that is on the surface, right? All right. If you guys have any questions about the troposphere, if you feel like I've gone ahead and messed something up or made a mistake, please leave it in the comment section below. Otherwise, we're going to leave it here for today, and I look forward to seeing you guys in the next one. Peace.